right, so we're going to talk about sine, cosine, tan, the ratio of sine, cosine, tan from 0 all the way to 360. So I've already filled these in. So if we type into your calculator the sine of 0 degrees, you get 0. Sine of 30, 45, 60, 90. I've filled these values in. Now, what these values actually are isn't that important. But what we can see is when we look in the other section, so they're called quadrants, from 0 to 90, we have these values, and then from 90 to 180, you can start to see that we have the same numbers. The ratios are the same. So the sine of 0 degrees, is the same as the sine of 180. The sine of 30 is the same as the sine of 150, and so on. You can see they're the same numbers. When we go bottom here from 180 to 270, or 270 to 360, again, we start to see the same numbers again, but one thing is different. They are negative. So we get all the same ratios, the same recurring over and over again. 0.866, 0.866, 0.866, 0.866, but some are positive and some are negative. This is sine. These are the sine ratios of all of these angles. Now, it works for other angles too. I just chose 30, 45, 60, 90, and 0 because these are special angles. Based on previous lessons where we talked about the special angles and we drew those special triangles and we found the exact values of things, of angles, we can find the exact value of these angles and from 0 all the way to 360. Well, we'll deal with that in a minute. So this is something called the cast rule. It tells us where sine is positive from 0 to 360. We see that it's positive here and here, and it's negative there and there. And you could do the same thing with cos and tan, and you'll see where they're positive and where they're negative. So from 0 to 90 is called quadrant 1. 90 to 180 is quadrant 2, 3, and 4. So we start calling them quadrants. 1, 2, 3, 4. So in the first quadrant, the sine of an angle is positive. In the second, it's also positive. In the third quadrant, it's negative. And fourth quadrant, it's negative. So the ratios are the same, but their signs are different. The sine of an angle in quadrant 1, or in the first quadrant, I guess, is equal to the sine of the corresponding angle in the second quadrant. So what that means is .30 degrees is obviously 30 degrees away from 0, and that has the ratio of 0.5. So the corresponding angle, if we reflect it on the other side, we have 150. That has the same ratio. It's also 30 degrees away from the x-axis. That's why it has the same ratio. So 150 is 30 degrees away from 180, and 30 obviously is 30 degrees away from 0. And the same for 45, 135, 60, and 120. They're the same distance away from the x-axis. So that's what we mean by the corresponding angle. So the sine of an angle in the third quadrant is equal to the corresponding angle in the fourth quadrant. Okay, and then you're going to do these again for sine, cos, and tan, and you'll see where they're positive and negative. So just to save time, you guys can do those, but what you're going to find is that all of the ratios, sine, cos, and tan, are positive in quadrant 1. But then what you're going to find is that only sine is positive in the second quadrant. Only tan is positive in the third, and only cos is positive in the fourth. So this is called the castral. C-A-S-T, castral. So it tells you that in the specific quadrant, which ratio is positive. So cos will be positive here. Cos of some angle between 270 and 360 would be positive. But if I found the sine of some angle between 270 and 360, it would be negative. Any angle between 0 and 90, sine, cos, or tan, will give me a positive ratio. So if I type in my calculator the cos of 37 degrees, it's guaranteed to be a positive ratio. But in this quadrant, from 90 to 180, only sine would be positive. So if I did, excuse me, if I did the sine of 120 degrees, that's going to be a positive ratio. But if I did the cos of 120, it's going to be negative. Okay, so this tells us which ratio is going to be positive in that quadrant. So, as an example, I filled in some of it already. 45 degrees would be in quadrant 1. It's 45 degrees away from the x-axis. So if I did the sine of 45 degrees, so theta is 45, right? That symbol here means theta. It's called theta. So sine of 45 degrees is 0.7071. The cos of 45 degrees is 0.701. And the tan of 45 degrees is 1. Now, we could get the exact values of this. This is from the special triangles, but that's not the point of this lesson. The point is the castral. So if I look at this here, 180 minus theta, that's 180 minus 45. So that would be 135. So 180 minus 45 is 135 degrees. So it's in the second quadrant. So the sine of 135 will be the same number because it's 45 degrees away from the x-axis. And positive because it's in the second quadrant. The cos of 135 is going to be the same number as the cos of 45. But because it's in the second quadrant, and cos is negative in the second quadrant, it's a negative ratio. And the same thing with tan. The tan of 45 degrees is positive 1, but the tan of 135, because it's in the second quadrant, is going to be negative. So now what happens if we add 45 degrees to 180? We're going to end up in quadrant 3. So in quadrant 3, so 180 plus 45 is 225. Quadrant 3, I know that sine is going to be negative. Cos is negative. The only one is tan is positive. So again, it's going to be the same number, same ratio, but negative. Same with cos. But tan is going to be positive 1 because it's positive in the third quadrant. And you'll notice tan is positive 1 here and positive 1 here because they're all positive in quadrant 1. But tan is the only one that's positive in quadrant 3. Negative, negative, positive. And finally, this angle here is 45 degrees away from the x-axis, or in this case, subtracting 45 degrees from 360. So 360 minus 45 is going to be, what is that, 315? Okay, so again, it's the same numbers, same ratios, but because we're in the fourth quadrant, only cos is positive. All the other ones are negative. So I'm making sure to put in green 45 degrees away from the x-axis because that's something that's going to be very important. It's called the related acute angle. So we're going to be using the related acute angle to figure out the primary angle, or sorry, the principal angle, not the primary angle. So the principal angle is the actual angle that we're figuring out. So in this case, like 315. But we're using the related acute angle, 45, to figure that, we will use it to figure that out. Okay, so we're going to end here, and I'll make another video explaining